All right, today we're going to do learning target 15, and it's graphing secant and cosecant functions. And these are actually really easy if you remember how to graph sine and cosine functions. But I know that we've been on fall break, so you may or may not remember. So the first thing, though, to remember is that cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. It's very important when we're graphing these functions. In order to graph cosecant or secant, you have to graph the associated sine or cosine function first, and then you can graph cosecant and secant. It's based off of that function. So make sure you know which one is which, because you'll have to graph the correct reciprocal first. All right, so if we're going to graph just basic cosecant x, so in a little bit we're going to start graphing with all the shifts and all of that, but if we're going to graph basic cosecant x, I need to graph the reciprocal sine curve first. And so we know some things about sine. We know it has a maximum at 1 and a minimum at -1. We know the period is 2 pi. So we use a scale of pi over 2. We know that sine starts at the origin. And here is our sine curve. Now, cosecant is a set of repeating parabolas that occur off the top of the maximum values and the bottom of the minimum values. And there are asymptotes to help guide those parabolas. If you don't know what an asymptote is, it's an imaginary line that provides a boundary for your function. So for cosecant, there are asymptotes at the x-intercepts. And then later when we start shifting and everything, they'll be at the midline intercepts. All right, so right now we have an asymptote on the y-axis. We have one at pi and one at 2 pi. Again, those are imaginary lines. I've made them dotted. Now cosecant, again, is a set of parabolas. So you can graph the parabola off the top of the sine curve. Notice that the parabolas aren't going to cross the asymptotes, and off the bottom of the sine curve, again, not going to cross the asymptotes. So if you really want to look at the graph of cosecant, we would erase sine, and there is what it looks like from 0 to 2 pi. So it's just two parabolas. Okay? So secant's pretty much the same, right? Sine and cosine are the same wave, just one is the shift of the other. So secant and cosecant are the same, just one is a shift of the other. So if I'm going to graph secant, I'm going to graph cosine x first. Also has a max at 1, minimum -1, period is 2 pi. Cosine starts at the maximum value, though. And so here is our cosine curve. All right. It also has asymptotes at the x-intercepts. And then parabolas off the maximum minimum values. You can include the entire parabola if you want. Just make sure you don't make it too wide. You have to remember that there are asymptotes that will provide boundaries for you. So that's basics, all right? So you want to graph the sine or the cosine function first so that you can know how to graph the cosecant or secant function. They're based off of each other. So since we've been on fall break, let me remind you of some things. this was the general equation for sine or cosine, right? And we graphed in a kind of a specific order, and you didn't have to, but it was kind of a guideline to help you out. So if you remember, the first thing we did was we found the vertical shift. Which was h. And then we would graph the midline at y equals h. After that, we would find the amplitude, which was the absolute value of a. And then we would find the maximum and minimum values by taking h plus a and h minus a. Okay? Then we would find the period, which we find by doing 2 pi divided by k. And then we would divide by 4 to get the appropriate scale to graph with. And then we would find the phase shift. C over K. And that was your starting point for your graph. So you already have all of those notes on a different note sheet from before fall break. But just to kind of jog your memory, because we're going to have to graph them here in a second. All right? So vertical shift, amplitude, period, and then phase shift. Most of the ones in our textbook will not have an amplitude because secant and cosecant technically don't have an amplitude. The amplitude indicates a height, and cosecant and secant increase to infinity and decrease to negative infinity consistently, repeatedly, over and over. So there's not a height, so there's no amplitude, that's the wrong word. There could be a vertical stretch, so there can be a value in front of secant or cosecant, but in our book, technically, most of the time, they don't, can be, okay? So let's do this first one together, and then I'll let you do the next one on your own. So it says to graph y equals cosecant of theta over 2 minus pi over 4, and then plus 2. So I'm going to graph the sine of this function. So I need to find some things out. So the vertical shift is 2. So I'm going to go ahead and graph the midline, just like I did in the first step. The amplitude is 1, so that means the max is 3, and the min is 1, right? The 2 plus 1 is 3, and 2 minus 1 is 1, so 3 and 1. Then we're going to find the period, which is 2 pi divided by a half, and that gives you 4 pi. So that means our scale is pi, because we're dividing by 4, so pi, 2 pi, 3 pi, 4 pi. And then we need to figure out the phase shift, which is c over k, so that's pi over 4 divided by a half. You multiply by the reciprocal, so pi over 4 times 2 over 1 is 2 pi over 4, or pi over 2. Now, pi over 2 isn't part of our scale. It's a half of an increment. So we're going to be graphing every half of an increment. And this is sine, which starts at the midline. So we're going to start at pi over 2, the midline, and then we're going to go to the maximum. Again, you're going every half, hash mark every purple one, because there's supposed to be pi units in between them. And so here is our sine curve. And again, this continues on without end. So it will continue. But now that I've graphed sine, I can go back and graph cosecant. So we're going to put asymptotes wherever the sine curve crosses the midline. And then we're going to include our parabolas. right? So there is cosecant. I don't expect you to go back and erase sine every time. That'd be a waste of an eraser. I understand that I just taught you to do is to go through and draw it. So don't erase it. Just leave it as part of it. But if you're looking at a calculator, looking at the textbook, they're not going to include that middle section, okay? Questions? All right, then you guys do the second one here, okay? And then I will give you the answer in a second. Okay, that is what the function should look like. I understand if you're watching the video that it just randomly appeared because I paused it while I was working on it and while the class was working on it. So make sure that you have the following information. The vertical shift was -1, so drew in the midline. The amplitude, as we're calling it, is 1. So the maximum is -1 plus 1, which is 0, and minimum is -2. So I indicated those on my graph. The period is 2 pi divided by 2. It's k. So we get pi. So we divide by 4 to get our scale. So pi over 4. That's what I was counting by. Then the phase shift is c over k. Remember, the original equation has a minus sign, so that's a negative pi divided by 2. So I need to start my cosine curve at the maximum at negative pi over 2. I put the asymptotes in where the cosine curve crossed the midline, and then I drew in the parabola. So the part in red is the secant curve. So again, it's all about being able to graph the sine and cosine functions. The second part of this is writing the equations. Because cosecant and secant are based on sine and cosine, then writing the equations is no different than writing the equations for sine or cosine. Right? We use the same ideas. 2 pi over k equals the period. Phase shift is c over k. So it says a cosecant function with a period of 3 pi, a phase shift of pi over 3, and a vertical shift of -4. So right now I know I have the equation y equals cosecant of some things minus 4, right? So we know the period is equal to 2 pi over k. And so we can cross multiply. You can do as much work as you need to do. Just always show my steps so that everyone knows what we're talking about. So k is 2/3. So I have 2 theta over 3, or you can write it as 2/3 theta. That's fine. Then I have the phase shift, right, minus whatever c is. So the phase shift, pi over 3, equals c over k. So if we cross multiply, we get 2 pi over 3 equals 3c. Divide by 3, and you get 2 pi over 9. So here is the final equation. So it's just like sine and cosine we did before fall break. All right, I'm going to have you do the next one, and then I'll let you start working. So here we have the final equation here for the secant function. Pi equals 2 pi over k, so k is 2, so you have 2 theta. And then pi over 3 equals c over k, which was 2, so we included that right here. So we cross multiply, we get 2 pi equals 3c. We divide by 3, and we get 2 pi over 3. So we have a minus sign here in the middle because that's what's supposed to be there in the original equation. Then we have the vertical shift of -3 at the end. So you can do Learning Target 15 homework, and we can just talk about any questions you have tomorrow.